25th to 1st. No. 1, 2, 3, 4, 5, 6, 7, 8 days. Count bro? Sugar day. 31st. Yes, that's 8 days. Well, it'll become actually 9 days because it's a Friday. Maybe. The worst place to be. Huh? It's so cold. It's -5. I mean, this is cold for me. That's I don't know what. My cold level is 0. No, 0 means it's not tolerable. Yeah, but the snow 0 to another common. Heat. Anything above 25 is unbearable for me. Yeah, that's why I have to stay inside with the ACs. Okay, so today we'll be wrapping up photoelectric effect, and we'll start the Niels Bohr model of an atom, the emission spectrum, absorption spectrum. So yeah, I'll go through this thing one more time. It's a very small topic, so it doesn't take a lot to review. So every class I'll do a small recap of this, okay? But it's a very important topic because guaranteed question from here. All right. So yeah, aske tomra amake buchhaba because I've done this 3 days in a row. So I can explain to me what's going to happen right now. Okay. So yeah, just screen it. Let's do a recap. So you have this metal surface, and you have a light source here. And what's happening right now is from the light source, there's light coming out. There's light coming out. Okay, so that you can see light coming out. And the light comes and falls on the metal surface. And on the metal surface, you have electrons here, delocalized electrons. Lots of delocalized electrons out there, which require what to be removed? Energy. Okay, so fine. And you are providing energy using the light source. So can you tell me, first question, when a light source is beamed onto a metal, right? What actually comes and interacts with the electrons? Is it the wave version of light, or is it the particle version of light? Particle version of light. Okay. So there are these particles of light that will be interacting, and these particles have a name. What is it? Photon. Okay, particles like a photon bola hai. So first question, describe or define for me what a photon is. Yes, that's the exact answer. Very good. It's a discrete or fixed packets of energy of electromagnetic radiation or electromagnetic wave. Photon bola jay. Okay, so these are photons out there, and these photons all have the same amount of energy. Turns out the energy they have depends on the what of the light source frequency, right? And that's based on the equation what E equals to HF, right? So HF formula tells us that it's a photon. You can only use E equals to HF for a photon, right? And a photon will only follow E equals to HF. So, you know, other equations of wave doesn't work here. All right, so we have photons coming in, and the photons collide with the metal, and turns out electrons don't get emitted. Okay, so I mean, like you see electrons bear. So what I do here is I increase the power of my light source. So light source out to brighter kore dilam. And as I make it brighter মানে হচ্ছে intensity বাড়ায় দিচ্ছি. Do you think emission will happen? Why not? What depends on the color? But I'm giving more energy, right? Higher power means higher energy. তাহলে কেন হচ্ছে emission হচ্ছে না? Right. Okay. Right. So what did I increase here? Intensity? If you look at this equation here, E equals to HF, is there intensity here? No, right? So that means intensity doesn't control the watt of a photon, the energy of a photon. So যদি intensity বাড়ায় দাও বা কমায় দাও, what is happening then? What's actually going on when you increase or decrease intensity? Something happens, right? What happens? Yes, but in terms of what's coming from the source, what changes? Right. So when you increase intensity, the energy of each photon is the same, but you have what number of photons now? More number of photons, which doesn't change the criteria for my electron though, because my electron doesn't care how many photons are coming in. What does it care? The energy of every photon, right? So right now, কোনো emission হচ্ছে না. By the way, side note, what is the name of the energy needed to remove the electron from the surface by photoelectric effect? What is the term for that energy? Work function. It's given by phi. Work function definition হচ্ছে the minimum amount of energy needed to remove electrons from a metallic surface using what? Photoelectric effect. Okay. So if emission doesn't take place, can you give me like a equation, relationship, inequality based on E equals to HF and phi? Emission যদি না হয়, like how does E and phi compare if emission doesn't take place? Right. So E is less than phi. Right. So যদি E is less than phi, I can say HF is also what? Less than phi. So my frequency is not the right frequency. Now let's say I keep increasing my frequency and I change this to like I keep slowly increasing this, right? And increase korte korte at a point I find that around like blue color, the emission just starts when it's barely just started, right? Can you tell me what's the criteria now? E equals to HF. Okay, so when emission just takes place, E equals to HF is equal to what? Phi. This is the minimum time or minimum frequency at which emission takes place. So we have a name for this frequency. It's আমরা FT ডাকি, and this frequency is called the threshold frequency. Threshold frequency definition is very common in your syllabus. It's the minimum frequency needed for what to take place. Photoelectric emission to take place, minimum frequency, right? Because any frequency below this, emission will never happen, like ever. There's no way emission will take place below this frequency. At this frequency, emission just takes place. That's just barely. Now, what if you go beyond this? What if you decide to give energy that's more than this like requirement? So let's say you go to purple or violet, ওই band চলে গেল, right? So if you go there, can you tell me what happens here? Like I'm giving extra energy. We all understand that, right? How this relationship compare তাহলে? মানে এখানে কি হবে? So your HF is now what than phi? Yeah, HF is greater than phi. Will emission take place? Yes. Most definitely, right? But what happens to the excess energy that you provide? Kinetic energy, right? So when this happens, this is the equation. HF that you have provided is going to go for work function plus whatever extra you have is going to become what? K, with a catch. The K is what K? Maximum K, right? So that is the chapter. যা দেখালাম এখানে এটাই কিন্তু mainly the chapter, আর কিছু নাই. There's some bits and pieces here that you need to think and apply, but main essence of the chapter is this. So we did this last class. If you're wondering, I gave you this criteria here. If it's less than phi, no emission. Equal to phi, emission হবে but no KE. Or greater than phi হলে emission with KE হবে. So if you put all of that together, this is the equation for you. Okay, HF equals to phi plus half NV max square. Clear? Okay, so আজকে আমরা যেটা করব, we'll push this equation to its limits. দেখি কি করা যায়. Okay, last class we did a math. I think it was very basic. I asked you to find out যে emission হয় নাকি, and also I asked you to find out the velocity of it. I asked you to find the number of electrons emitted per second. ওইটা করতে বলিনি তোমাদেরকে because there's something I need to show. So এটা এখন করব আমরা আগে. Okay, so are you clear so far? All the definitions are provided here. Photoelectric effect হচ্ছে electron removal by emission of light. Photon হচ্ছে packet of fixed energy of electromagnetic wave. Work function হচ্ছে minimum energy needed to remove an electron from a metallic surface. Threshold frequency, minimum frequency needed for this to take place, and we the whole story of what actually happens এখানে লেখা আছে. Okay, now intensity বাড়ালে কি হয়? Just one more time. So let's say emission is not taking place and I increase my intensity. Will it do anything? No. But let's say emission is taking place and I increase my intensity. What might happen? let's say emission হচ্ছে but intensity বাড়াই দিলাম, will the K of my emission increase, or will the number of electrons increase that are emitted? Number of electrons. You say K. Number of electrons. Okay, how many of you think that if you increase the intensity and emission is happening, right? To me, intensity যদি বাড়ায় দাও, K বাড়বে. How many of you think that? Okay. And how many of you think that if the intensity is increased for the same color, if I increase the intensity, what happens to the situation? Does the K increase or the number of electrons increase? How many of you think that? Achha, okay. It's actually number of electrons. And then it was the issue with, yeah, right. So online, it's the issue with Einstein's original equation. So no one could prove this. And I'll tell you what the problem is. I can make claims, right? Like for a electron bear, but there's no number to prove it. There's no equation to satisfy, right? So somebody had to come up with an experimental setup to prove this. And we experimental setup to this ingenious design, which eventually in modern day became the solar panel. So it was an experiment somebody performed to prove this equation. And later on, we realized that you can actually generate what from light? Electricity. We're going to do that. It's called a photocell. Okay, so photocell today, we can prove everything and anything that you have from this topic. The intensity barley ki hoy, frequency barley ki hoy, all of those will be proven using this equation that I'm going to show you right now. Not equation, setup, experimental setup. So let's see this. So what is a photocell? So photocell হচ্ছে রিয়েল লাইফে দেখতে একরকম আর সিম্বলটা একরকম। So real life দেখতে কিরকম দেখায়? It basically consists of this metal sheet. একটা metal sheet থাকে এখানে, and metal sheet এর উল্টা দিকে you have an electrode, like another metal sheet, if you could say. And this whole thing that you see here is encased in a vacuum chamber so that there is no water interacting with it, air particles. Okay, so this is how it looks like. And এখান থেকে একটা তার বের হয়, আর এখান থেকে আরেকটা তার বের হয়. And this has a name. The official name for this device is called the photovoltaic cell, or photocell in short. Photovoltaic cells are basically these. Do you see that? Right, the solar panel. That's a photovoltaic cell. So এখানে কি থাকে? এটার ভিতরে there's actually a metal, and somebody figured out that if you actually shine light on it, the metal might remove what from it? Electrons. And electrons that come out with excess energy can use that energy to travel through a circuit, and you can then use that excess energy. And that's what circuits do. Electrons carry energy and you use the energy, right? So somebody thought, how about we try this? So he set up this circuit here. He used the metal zinc in this case. So he can zinc use course, the first version of it. And he used red color light. But before that, let's complete the circuit. So circuit, there are some parts that we need to know. So circuit in niche hoche, you have no, just a resistor. Okay, and to know if there's any electron flow, what can I use in the circuit? When if there's any flow of charge, how would I know? There might be a watt in my circuit. Question. If there's something flowing through my circuit, right? There's a name for that flow thing. What is it called? Current, right? My question was, what might you use to find current? Yeah, ammeter. Okay, not sure. Galvanometer too. So you have an ammeter here, but I have to give you like a disclaimer here. The current is really small, so they use a micro ammeter, which is like very sensitive and can pick up very small amounts of charges that come out. So this is the circuit. Okay, now let's see what was done. So a part is important. The first time the person did this experiment, he replicated what we did earlier. He shone red color light here. And after he shone red light here, right, কোনো current আসে না. Regardless of how much intense your red light is, current আসে না. Why? Yeah, because red lighted J frequency is actually less than the threshold frequency needed. মানে আমার red lighted J photon energy is not enough. So তুমি intensity বাড়াই দিলেও কি কোনো কিছু হবে? No. So কিছু হয় না এখানে, okay? And then the person shifted to a different color, and blue দেওয়ার পরে the person sees that there's this very small amount of current showing up here. What does that tell you? If blue gives you a small amount of current, like a really small amount of current, it means emission is taking place, right? Acha. এখন, this is the part that's important. The person then increased the intensity of the blue light. And as he kept increasing the intensity of the blue light, he found that the reading here kept increasing. Explain this observation. Why, as you increase you didn't increase color frequency, you just increase the intensity, right? As you increase the intensity, why did the current value change? Very good, right? So what happened was previously you had, 3 or 4 photons coming in originally. Intensity double করলে the number of photons কি বেড়ে যাবে? Number of photons যদি বেড়ে যায়, each of these photons are successful in emitting what from this metal? Electrons, right? So এখান থেকে electrons বের হবে, and because you're giving the right frequency, electrons তো বের হবে. So what's happening is electrons are moving here, and these electrons then flow through the circuit and you get a current value. So we have found that there's actually a relationship between intensity. What is it? Intensity does actually play a role in photoelectric effect. Intensity is directly proportional to the এটার নাম বলা হয় the photocurrent. Photocurrent মানে হচ্ছে তোমার এই লাইট থেকে যে কারেন্টটা জেনারেট করা হয়, but there's a catch. কি আমাকে বলতে পারো what's the catch? No, like this intensity is proportional to photocurrent, right? Under a very certain criteria. What is it? Blue light. কাছাকাছি. Yes. Given that the light has what frequency equal or higher than threshold frequency. কারণ আমার যদি emission নাই হয়, আমার কিন্তু intensity change করে কিছু হবে না. This is only valid and it only holds as long as emission takes place. So this equation, this relationship is only valid if your frequency that you're providing is greater than or equal to what? Threshold frequency. And threshold frequency key, the minimum frequency needed for emission to take place. Okay. So now we have established one thing, that intensity বাড়ানো হয়, more photons come in, more photons will produce more what? Electrons. And what's the evidence of more electrons flowing through a circuit? Higher current. Okay. Next, the experiment was modified, and this modification is an ingenious design. They placed a battery here, and they placed a battery that's a variable power supply. তোমাদের সিলেবাসে কোনোদিন এখনো আসেনি, বাট এডএক্সেল এই কোশ্চেনটাতে যখন সার্কিটটা আঁকতে দেয়, ওরা ব্যাটারি অ্যালাউ করে না, ওরা হচ্ছে অ্যাকচুয়াল ডিজাইনটা চায়. Do you know of a design in a circuit, right, where you can change the length and it changes the voltage? What is that thing where you can change the length and that changes your voltage? Yeah, potential divider, potentiometer. ওইটা এখানে ড্র করতে হবে, ওকে? সো এখানে যেটা ড্র করতে হয়, লাইক এডএক্সেল এর কথা বলতেছি, ওরা এখানে আসার পরে they have this resistor here, and এখান থেকে একটা কি থাকে, পয়েন্টার, and পয়েন্টার থেকে লেফট রাইট সরালে কি হয়, ভোল্টেজ ভ্যারি করে, রাইট? আমাদের তো এখানে that's not our main criteria, তার জন্য I'm not going into the details of that. I just want to show you this with this thing here. What do you call this? A variable power supply. Okay, modern data, you don't need all that thing. You can just buy this thing called an adapter. It can plus minus gurale voltage change. We're using that. Okay, so the person found that if you set this to 0 volts, look at this very carefully. Okay, if you set this to 0 volts, current normal and everything is fine. So there's nothing changing here. However, he found that as you keep increasing the voltage here, a voltage the current starts to decrease. And you keep increasing the voltage, current keeps decreasing until at one certain point, the current becomes 0. When the current becomes 0 ampere, a voltage right, has a name. The voltage is called stopping voltage. And it's one of the most important part of this setup here, the voltage, stopping voltage, okay? So what is stopping voltage? The answer is it's the voltage at which the current in the circuit becomes what? 0. Now an important question. Why? Why is the current becoming 0? So it turns out, আমরা একটা জিনিস কোনোদিন prove করতে পারিনি prior to this, যেটা ছিল যে if you have a metallic surface and if you have an electron here and you have a photon coming in, right, with energy, এই ফোটনটা যে আসবে এখানে, ইলেকট্রন কি এনার্জি দিবে, ইলেকট্রনটা এনার্জি নিয়ে কি বের হয়ে যাবে না? We made a claim, a very bold claim, that যদি excess energy থাকে, what does that convert itself into? Kinetic energy, right? Where is the proof? যখন একটা সারফেস থেকে মেটাল থেকে ইলেকট্রন বের হয়ে যাচ্ছে with excess A, right? How do you prove it? Because there's nothing that you can actually measure. Electrons detect করা difficult, capture করা difficult, velocity বের করা impossible. So how do you prove to someone that actually আমার যদি energy excess থাকে, it turns into K? We didn't have any proof until this thing showed up. এখানে see what's happening. There are electrons now coming out from this metal, and these electrons have excess energy. It's in the form of what? এই যে photoelectric effect হলো না এখানে থেকে excess electrons গুলো বের হচ্ছে, right? Electrons গুলোর যে excess energy is in the form of what energy? Kinetic energy, right? So the Ke max that we just talked about. Do you agree? So let's say I'm providing a frequency here, and that frequency is higher than your threshold frequency. Shouldn't the electrons come up with extra Ke here? So that's the extra Ke. And what is coming out from here? A battery থেকে electrons বের হচ্ছে, right? ওদের যে এনার্জিটা এক্সিস্ট করে, what is that energy? Grade 9 electricity. What is the energy that electrons carry through a circuit? Charge. Electrical energy, right? Charge is the property, okay? So this is called electrical energy. Now, can you tell me if these electrons are going this way and those electrons are going that way, what do they do to each other? Oppose each other? These are repelling that are repelling those, right? Can you tell me when would the current become zero? Right. So when the current is zero, can I say that the K of my electron is equal to what? Electrical energy? Right. So can you give me a formula for electrical energy? E equals to VIT acceptable, but the original formula. E equals to E equals to, you both are arguing on the same wrong things. So Q by V or V by Q. Oh, what is E equal to? QV. It's just QV. Okay, so it's Q times V. That's the kinetic energy. Okay. Now, আমাদের এই সার্কিটের মধ্যে what is the charge going to be? Car charge, electron, right? And what is the voltage going to be? The stopping voltage, right? So এখান থেকে what we eventually found is that the Ke of your particle can be now replaced with what here? EVS, right? Can you tell me what was the formula we derived last class? HF is equal to what for the entire photoelectric effect? Yeah, HF is equal to phi plus K, right? And আমাদের problem কি ছিল? There was no proof that এখানে K টা বের হতো. But now that we know that K is equal to this, right? What can I do? I can replace this with what? EVS, right? And if I replace that with EVS here, see what happens. It solves all the problems that we had pending. In this equation, E equals to phi plus half mv square, right? Tell me what are constants, okay? H key, constant, right? So the Planck constant, fine. Phi key for a metal, is it variable or is it a constant? Constant, right? When phi is the amount of energy needed to remove electron from a metal, right? Zinc energy change and same. Same. What's the charge of an electron? Constant, right? So eventually we found that if whatever we are claiming is true, right? The frequency must be proportional to the what? Stopping voltage, right? And yes, as predicted, আমরা যখনই এখানে frequency বাড়াই দেই, we find that the voltage needed to stop increases. And তোমার যদি voltageটা বেড়ে যায়, what does that mean in terms of K? K-টা বেড়ে যাচ্ছে. So finally, we have a proof that K actually increases. Prior to this, কোনো proof ছিল না. We only had it in, equations. But this is an experimental evidence that তোমার যদি frequency বাড়ে, K বাড়ে. How do you explain this in your exam? If your frequency increases, K increases. If K increases, the what needs to be increased? The stopping voltage. And we find that the stopping voltage increases here. The excess energy with which they come out. Okay. Which experiment? Oh, yeah. So এখানে Ke হিসেবে বের হচ্ছে, right? Is there a way to find Ke of an electron? Half, right? Mass of electron জানি, right? Can you find the velocity of an electron? Let's say এখান থেকে electron উড়ে যাচ্ছে এখন right now. Okay, you want to capture its velocity. What would you use? Light gates, ticker timer tape. It's possible. So unfortunately, there's no way we can find the velocity of an electron. right? So we came up with an idea. যে ইলেকট্রনের যে এনার্জিটা ওইটাকে আমরা অপোজ করব ইউজিং আ ব্যাটারি and যদি এই এনার্জি আর এনার্জি সেম হয়ে থাকে what would the current value become here? Zero. এই কারেন্টটা কেন জিরো হয়ে যাচ্ছে এটার যে এনার্জি আর ওইটার এনার্জি কি সেম, রাইট? সো দ্যাট কনফার্মস দ্যাট দ্য K is equal to the electrical energy. আর electrical energy বের করা খুব ইজি. What is it? QV, right? So we are basically replacing the EV with the QV because QV is something we can actually measure. So finally we find that this is the key takeaway from here, that the energy of your electron, kinetic energy, depends on the watt frequency. Okay. আচ্ছা, so তোমাদের সিলেবাসের মধ্যে এই জায়গাটা ওরা একটা গ্যাপ রাখছে. They don't talk about this. They directly jump to another thing. ওটাতে আমি এখন যাচ্ছি. I will explain this again. মানে তোমাদের নোটস and everything দিব. But তোমাদের একটা গ্রাফ দেয় ওরা. So if you ever done quantum physics chapter, দেখবে যে almost every other year there is this graph. ওই গ্রাফ থেকে অনেক কিছু বের করা যায়. গ্রাফটা কি একটু বলি তোমাকে. So if you haven't understood this, it's fine. But obviously বুঝা দরকার. But the thing that I'm going to show you right now is more important. So we know that HF is equal to phi plus EVS, right? That's what we know from here. If I plot a graph here for my independent variable to be frequency, can you tell me what should the graph look like? It is the frequency or hertz hoy, or a y-axis the excess kinetic energy, which is basically going to be what in my equation here? EVS, right? Can you rearrange this and tell me what should this look like? Y equals to mx plus c that you convert করতে চাই, right? How would this look like? So আমাকে কোনটাকে সাবজেক্ট বানাতে হবে? না, EVS, right? Because y-axis beta, right? So EVS is equal to what? HF minus phi. This whole thing is my what axis? Y-axis. F is my what axis? X. তার মানে H is my what? Gradient. And phi is my what? C, right? And from there, we come across that very famous graph, a graph that allows us to find the what constant, Planck constant. Graphta এরকম দেখতে, a straight line, right? একদম perfect straight line থাকে, and এটা একটা point এসে আর কাজ করে না. কেন? Because this frequency that you see here is what frequency? Right. So if you go beneath this frequency, if you reduce the frequency, কোনো emission হয় না. If you give that frequency exact value, কি হয়? Emission just হয়. আর তুমি frequency বাড়াতে থাকো তাহলে ওই emission হচ্ছে, but every electron that's coming out has more and more what? K, right? But there's a minus phi there, which means that you can actually extrapolate this graph, and extend this graph on the negative axis, and you'll find that it goes and intersects কোথায়? Y-axis, and the value that you get there is your what? Work function, okay? Minus phi. So you can also find the work function from this graph by finding the negative y-intercept here. So I have a question for you, okay? A gradient, by the way, key down there, Planck constant, right? Can you tell me how would the graph look like? Listen carefully, okay? How would the graph look like for a metal that has a higher work function? মানে গ্রাফটা কিরকম দেখতে হবে if the metal has a higher work function? Steeper. What? Same? Yes, very good. So same gradient হবে. Translation. কোন দিকে? So one thing, let me clarify, inclination change হবে না, because the gradient gives you what? Planck constant. It's a constant, it never changes, right? So the graph is just going to go left or right. So what do you think? Is it going to move to the, like, shift to the left or shift to the right? Work function, higher value, full stop. To the left. To the right. Okay, how many of you think that a metal with a higher work function will give you a graph that's to the left? Shifts to the left. Higher work function. Okay. And higher work function to the right. Acha. So a little disappointed. I thought data was very obvious. Of course it's going to be to the right. Higher work function mane what threshold frequency? Higher threshold frequency. Forget that. Forget the plus minus. Ignore that. Just the fact that it has a higher work function, doesn't it require greater frequency? So you have to be careful with the phi here. Take the phi for its magnitude, not the sign. Because sine to mone hobe higher value mane eta hobe, right? But it's the magnitude. And why should you only look for magnitude? Phi is energy. Energy to plus minus is going to matter for it, right? So if you're confused about this, my recommendation is just follow what? The threshold frequency. Any metal with a higher work function will have a what threshold frequency? Higher threshold frequency, because it requires more energy to be emitted, right? So this one is shifts due to greater phi. Also, one follow-up question. Can you tell me if I increase my intensity, what happens to the graph here? I mean, intensity bar, right? How does my graph change? How does the variation of intensity affect your graph? Nothing. What do you think? A question that if I increase the intensity of my light, what happens to the graph? Yeah, the answer is absolutely nothing. Intensity has nothing to do with photoelectric effect. The only thing that intensity can do is just make sure there are more number of what release electrons, which is not part of this graph. So it will make a difference. Okay. So yeah, that is the end of the topic. Yeah. Oh, for light experiments. Your plastic. Okay, just graph it copy to record. It's the only graph we have on the topic, and it's very common. So, we etar ager page atomic. You can add your page number, whatever you want to call the page. You have the freedom. Just add a page number. I have for 410. This is no after. No. Are you guys done? Okay, so I'll give you a question to see how far you have understood. And you can start the atomic energy level part. No, only 18 months. No. Yeah. Shesh. Done. Okay, try this. Kadri Gaurav. It's a summary of what we have done so far. It's a question. The lamp is a light is shown onto a metal. The electrons emitted generates a current. The lamp is 40 watts and emits 500 nanometer wavelength. The work function is 2 eV. Find the number of electrons emitted and the excess Ke. You also need to find out, light at 250 nanometer was the number of electrons that are emitted. I'll give you the values here. There. There are mass of electron 9.11 into 10 to the power minus 31 kilogram. Charge of your electron is 1.6 into 10 to the power minus 19 coulomb. Planck constant is 6.63 into 10 to the power minus 34 joule second. Very good. Where's the dividend exam? HF equals to 5 plus half mv squared. The number of electrons. Yeah, it will be very small. Minus 20. Huh? What? Slower. Minus 20 to only high. If you do half mv square, find the velocity of the electron, it's moving very fast. Kinetic energy low, but it's the mass only low. So you'll find the velocity is actually quite high. Okay, so find the number of electrons emitted. What is the number of electrons emitted? How do you find it? Using power. How much do you get? That's the first thing we did from the photon topic 2 classes back, finding the number of photons emitted. Now, number of photons would mean number of electrons emitted, right? আচ্ছা করে দেই first তোমাদেরকে বের করতে হবে energy of one photon E equals to hf, but there was another formula I gave you. What was that? H c by lambda. H হচ্ছে 6.63 into 10 to the power minus 34 into c হচ্ছে 3 into 10 to the power 8 divided by how much is the wavelength initially? 500 nanometer. 500 into 10 to the power minus 9. That will tell you how much energy one single photon contains. How much is it? 3.98 into 10 to the power minus 19 joules. Next, it says that the lamp is 40 watts. Every second, right, the lamp produces what? 40 joules, right? It can add better to find the number of electrons emitted per second. So if one second there 40 joules emit kora hoy, okay, let's write this the other way. If one photon gives you how much energy? 3.98 into 10 to the power minus 19. Then how many photons do you need to generate how much energy every second? 40. So এখান থেকে হচ্ছে number of photons বের করতে পারবা। We did this if you remember, right? The number of photons first class equals on the photon chapter or photon যেদিন শিখাইছিলাম তোমাদেরকে। So this is going to be 3.98 into 10 to the power minus 19. This will tell you the number of photons that are emitted, and if the number of photons are all successful, the number of electrons would be the same as well, right? So কত আসে এটা? 10 to the power 20. Yep. So that many photons are emitted from this source here every second. Okay. Now, how to find excess K? Excess K বের করাটা is an independent question. So এটা photon number বের করলাম আমরা, number of photons. What about excess K? How do you find excess K? Yes, you just use that original formula there, right? So this is going to be HF or HC by lambda equals to phi plus K. We already found that, the energy. So that's going to be 3.98 into 10 to the power minus 19. What is phi? 2 eV, right? Can I use 2? Yeah, I have to convert that into what? Joules, right? How do you convert EV to joules? Right, into 1.6 into 10 to the power minus 19 plus K. And এখান থেকে যেটা আসবে ওটাই answer. So K is equal to 78 into 10 to the power minus 20 joules. Yep, that's the K that's generated by the electrons here. Are you clear so far? Okay. Now, there's something interesting that's going to happen. Number 2 to that go. We will use the same light, okay? When I say same light, when I say same intensity. Same intensity, but I'm using what wavelength right now? 250. Do you think, without doing any math, emission will still take place? Yes, because this is shorter wavelength, which definitely means what frequency? Higher frequency. So emission will definitely help it, right? So if your emission takes place, I want you to do this. Find the number of electrons emitted with this light every second, and you'll find an interesting observation. Correct? So same math take korbo amra jeta ekটু age korlam, but this time we'll do for what? 250. So we'll basically repeat everything here. So এটা হচ্ছে photons at 250 nanometer. কি change করবো এখানে বলো? Yeah, just one small change, okay? So I'm going to change the wavelength here. Instead of 500, I'll make this 250. So that's going to be 250. Will also change. কত আসে দেখো? 5 point. আচ্ছা হ্যাঁ। So আমি যদি হচ্ছে 20 তে করি তাহলে কি আসবে? 0.5. 0.5 into 10 to the power 20. Okay. Now, why did I do this? সবাই একটু দেখো, there's a very important reason here. পাশের বক্সে লিখবো. When my light had a wavelength of 500 nanometer, the number of photons emitted কি ছিল? 1.005 into 10 to the power 20. When my wavelength is 250 nanometer, then the wavelength emitted or the number of photons emitted is 0.5 into 10 to the power 20. What is the relationship that you're seeing here? If you decrease your wavelength, right, what happens to the number of photons as well? Decreases. And they follow what relationship? Directly proportional relationship. কারণ এটা যদি কমে ওটা যদি সেম ভাবে কমে কেন? What's the logic behind this? So the logic is something that I mentioned, but আবার দেখাই তোমাদেরকে. Imagine you have this light source here, blue color, okay? Listen carefully. It in the last 2 years, I think every year active question. So hopefully they'll keep up the same trend. So you have another light here, which is violet, let's say. And we are going to shine this on this surface here. Etar power hoche, I'll do simple math here, okay? 100 watt. The power of this lamp that you see here, this one is 100 watts. And this is also 100 watts. And from the blue light, blue photons are coming out. So the blue photons can you tell me which photon will be more energetic, blue or violet? Violet, কারণ violet কি বেশি, frequency বেশি. So more energetic মানে হচ্ছে the violet photons are going to carry what energy individually? More energy, right? So violet photons will এরকম দেখতে. That's it. Now, at the end of the day, both of them are still providing me what power? Same power. But this one has photons, hypothetically speaking, each of 10 joules. And these are each, let's say, 20 joules. Can you tell me how many blue photons will be needed every second? What? Yeah, 100 divided by 10. So I need 10 of these blue photons. Every photon is 10. So 10 into 10, I need 10 photons here. But to produce that same power using violet, right? How many photons do you need? Just 5 photons. And you will find this trend that as you increase the frequency, the number of photons decrease start kore. Given that they're at what power? Same power. আর এটা না হচ্ছে you get an MCQ ঠিক না, মানে একটা 1 মার্কের রেশিও কোশ্চেন দেয়, কোশ্চেনটা এরকম দেখতে হয়। আমি এটা এখানে অ্যাড করে দিচ্ছি তোমাদের বোঝানোর জন্য। এই যে find the ratios of lambda A to lambda B, FA to FB, NA to NB. So মানে কি বলি? If this is 750 nanometer and that's 375 nanometer, what's the ratio of my wavelength of A to wavelength of B? Very easy. 750 by 375. What is it? 2:1. But frequency will be 1:2. Because frequency and wavelength are inversely proportional, the speed is constant. So তোমার যদি wavelength 2:1 হয়, frequency 1:2 হবে. কিন্তু number of particles emitted for the same power is going to be what again? 2:1. বলছো না wavelength the same হয়? এটার লজিক কি? এটার লজিক হচ্ছে if your frequency is 2:1, মানে হচ্ছে তোমার frequency যদি বেশি হয়, will you have more photons released or less photons released? Less of them released. Remember, the bigger the size, right? So we can find that the number of photon follows a ratio the same as wavelength and inverse to your what? Frequency. So this relationship is very important. For the same power, number of photons is inversely proportional to frequency. Higher the frequency, fewer the number of photons that are released. Okay. So yeah, this is something that syllabus is going to mention, but shows up in your paper quite often. Clear? Okay, so I'll give you 5 minutes break and then we'll start the next topic, energy levels. What? Share again? 30% MHT. Really? Oh, I'm just about 3 days. What then? No. No. No, you're asking at the wrong time. Never. 25th to 2nd. Nucleus. Second. Okay, let's start. This is the last part of the topic. It's basically just two ideas that we need to focus on. Okay. So you can see the syllabus provides here. Just this is the syllabus. It's just two things out here. Okay, shall I do screen দেখো? Let me explain what this is all about. So কিছু লেখা লাগবে না, just বুঝো। আমি বললাম it's a very basic concept, but it will contradict some of the things you have learned before, as it is with quantum physics all the time. Okay, so এটা হচ্ছে an observation that was made. So back in the early 1900s, we came across the model of an atom, and the one that you learn in your AS. So can you tell me right now, from whatever knowledge you have, what's the most accurate version of the structure of an atom? Balloon. What structure is that? Those are bonds. I'm asking you like what an atom is like. Yes, very good. It's the Rutherford model. So Rutherford model key wallet, there's like a very small nucleus, right? And the nucleus contains protons and neutrons, right? And around the nucleus, what do you have? Electrons, right? So this was proven using something called the Rutherford scattering experiment, right? And it didn't last very long. Idea, you know, because it was first very slow. Rutherford using the gold leaf experiment, right? He found that the nucleus existed, but he struggled to explain what? The presence of your electrons. Do you know what was his final idea behind what the electrons were doing? According to Rutherford model, right? What are the electrons doing? They appear when they're making bonds. No. But you're like 40 years advanced. When Rutherford came up with the structure of the atom, I think the different models of atoms out there. Yes, exactly. Yeah, it's called the planetary model, solar system model. Anyways, I'll take that. It's not a problem. So I mean, ekdom elementary level in okay. So let's say ekdom first 1897 J.J. Thomson, right, came up with the Plum-Pudding model. Do you remember the Plum-Pudding model? And his model told that, why did he come up with this? Because he was the person who discovered the electron. And prior to this, right, we didn't know how electrons, protons exist. In fact, we didn't even know electrons existed. He discovered it, and he had to come up with a solution, right? That electrons both have atom. He said that the atom is actually what? It's like a jelly-like structure, permeable, right? That are positively charged. What is embedded at every location? Electrons. And the electrons are vibrating and everything. This is called the J.J. Thomson model. To prove this, physicists did the gold leaf electroscope, and they found the outcome was quite drastically different. They found that almost every particle that you fire at this goes straight through. Very few particles deflect by a small angle. Very, very few particles deflect by a large angle. And from that outcome, Rutherford came up with this model. What is this model known as? The planetary model. So if you look at this model, you will see that there are electrons spinning around like that. Now, he had no proof for this. This is very important. Okay, Rutherford didn't have any mathematical idea, nothing to prove that this existed. He simply used the planets as a what? Inspiration. Because the question that most people had was that if the electrons are far out there, why aren't they crashing into the nucleus? When your nucleus is positive, the electrons are negative, so they should just go and stick to the nucleus, right? But he said that the electrons are out there somehow, and he used the inspiration from planets. The planets in theory should go and crash into the star because of the strong gravity, right? What keeps them from crashing into the star? centripetal force. They're always moving, and because they're always moving, they try to fall, but they never fall, right? So Rutherford said the electrons are doing this until I think a couple of years later, 1913, Niels Bohr came along and changed it. Amra jeta ajke shikhte jabo is this model. Okay, this model, by the way, is also wrong because 2 years later, I think there was this Sommerfeld model where I think tomra je pi sigma bonton jela shikho SPDF oitar much more accurate representation chilo. This was also wrong because a few years later, Schrodinger came and said that everything, it's a cloud. It's a cloud, it's a probability, electron thakte pare, now thakte pare, it depends. It's on your luck that you exist, okay? So that's what the Schrodinger model is. Anyways, amra eto advanced jabo na. No, that's actually the most correct version, and unfortunately, physicists don't like that because they say that the presence of matter is a chance, not a probabilistic bhabe hocche certainty. There's always a chance. Sorry. Oh yeah, there's just simultaneously all their electrons just statistically disappeared. That's where the person disappeared. Anyways, let's see what's going on here. So Niels Bohr came across this investigation. He did this thing, which is the chamber here had hydrogen gas. Now listen carefully. I'm going to chapter to start with. So he took a chamber filled with hydrogen gas inside, and what he did was he provided a very high voltage across it. Not recommended. Hydrogen is very flammable. It explodes, right? But he did that. And he provided a voltage of around 10,000 volts across the chamber. It's called the cathode chamber or discharge tube. That's the term. So he provided this voltage here and he saw something strange. He saw that from this chamber, it started to glow, the hydrogen, and it started to give off what? Light. And he found that every time he changed the element, the light changed. And this was the first ever, authentic version of the flame test. So the flame test is like a miniature version of this. Flame test, we take metals, we put them in the flame, they get excited, they get heated, and they give off light. Hydrogen ki kora possible. Hydrogen the flame there will be like a pop sound and it explodes, right? So hydrogen ke tube heat kora hoy, it gives off a light. He was curious, why is light coming out? Why is light coming out when you heat a gas? That's the thing, right? And that's when he realized that the structure of the atom that we know was actually not accurate. The part that was accurate is that in the center, what did you have? A nucleus. That is all fine. That's why you still study the Watt model, Rutherford model. But the electron placement was completely wrong. According to Niels Bohr, who came up with this, he said that the electrons are found in orbitals. Okay, so যেরকম orbitals পাওয়া যায়, এই orbitals এর মধ্যে তোমরা electrons গুলোকে পাবা তোমরা. And he said that the orbitals are based on the energy needed to remove the electron. মানে হচ্ছে these are energy levels বলা হয়. And furthermore, he said that they occupy a very random location out there. So they're not concentric circles. They're not equally spaced out. What's happening is that the gap between them is random. And there's a reason behind it, but originally it was random. And the light came from here. So according to him, these shells that you see, they contain what? Electrons, right? And the electrons are moving around in the shells like here and there. But the part that is going to bother you, he said that the electrons that you see in these shells, right? They're not particles. They're what rather? Waves, okay? So the question is then, why do they occupy this space? So according to Niels Bohr, for an electron to form its path around a nucleus, it needs to form a stationary wave. Do you remember stationary waves? Stationary waves are waves where the energy is what between 2 points, confined, right? He said that if an electron has to form like a shell or orbital, as you guys know, it needs to form a what around this, a stationary wave. And if you remember from stationary wave chapter, you can't have a stationary wave whenever you want. There's like a particular length and a frequency that needs to happen, right? So amar jodi ekhane stationary wave form hoy, the next stationary wave won't happen right away. It will happen at some other multiples of the base frequency harmonixation, right? He said that every shell that you see in an atom is actually the location where the electron, which is a wave, forms a what there? Stationary wave. And that's where they occupy very unique locations out there. So this was the first groundbreaking thing he said. And secondly, he said that if you provide energy to an electron, this one is very strange, okay? If you provide energy to an electron, the electron will migrate from a lower shell to a higher shell. Only if you provide what amount of energy? Exactly the same amount of energy as the gap. What if you provide slightly more, slightly less? Kichu hobe na. So what if you provide the energy requirement 5 joules to me 5.1 dila? It won't do anything. You give 5 at 4.99, it wouldn't do anything. As long as you not provide the exact value, the transition never happens. So whenever an electron has to go from one shell to another, you must provide exactly the same value, right? And it eventually turns out one-to-one interaction, as you know. So when the light comes and hits your electron, the electron will only take in the energy it wants, and then it'll go to the higher level. Also, another thing that he said, which is still debatable, we don't know if it's true or not. He said that the electron, when it gains the right amount of energy, disappears from that shell. And then what does it do? Reappears in the other shell. Between shells, there's no evidence of their transition. We have not found yet. It could be like we don't have the right instruments to measure, but when an electron transits from one shell to another, মাঝখান দিয়ে যে যাচ্ছে এটা capture করার কোনো উপায় নাই. What happens is just disappears and then it reappears. হইতে পারে, but there's nothing we could have captured from there. Oh, he said that there's no particle interaction. So the way a particle moves from one shell to another, if you think of the electron as a particle, you have to introduce what for the electron? Ideas of speed, velocity, mass, and everything. None of those make sense here. Because the way it works, the electron actually transfers from the shell to the other shell faster than the speed of light. Yeah, it's instant. So the moment you give energy, instantly it shows up somewhere else. That defies the speed of light. So Tarjano, he said that it just disappears here. To satisfy the laws of physics, it just reappears there. Because if it were a particle and did that, it wouldn't really happen. Because anything with mass can't travel at the speed of light. So that's the thing. So he says that it disappears, disintegrates, the energy probably goes there and then reappears as mass. So there's still a mystery. We don't know. Nothing to be concerned about for us because we don't have it in our syllabus. Okay. So this is the atomic model of Niels Bohr. One more time, according to Niels Bohr, the nucleus is as before, but the electrons are now in shells, which you know, I think from chemistry, shells is Shigodomra. But the shells occupy very unique locations. Why? Because these are the locations where the electron can form a what wave? Stationary wave. And stationary waves are generally harmonics, they have to be at certain location. Something else more important is that every single atom has a unique shell. There is no two shell structure that you can have common for two different elements. It is just not possible. And the reason behind this is very simple. Shielding. What is that? Oh, acha. ওইটার জন্য না আমাদের gaps গুলো তো large enough. But my question is that why can't you have two elements with the same shell values? So I think shielding could be the right answer. The actual physics version of the answer is that the places where the electrons can form their shell depends on the attraction from the nucleus and the proton number. So proton number dictates where the electrons can be. More the attraction means that the electrons tend to be a little closer. Less the attraction means a little further, right? And proton number key to elemented two different elements. Can it be same? No. So if the proton number is unique, what is going to be unique for sure? The shell location. You get my point? So you'll never find two atoms with shells that are what? Identical. It is just not possible. Okay? And that's something that we exploit in flame test. Flame test is a different colors. So before I get into that, I just want to show you the atom one more time. This is the Niels Bohr version of the atom. Okay, the one I'm going to show you right now. Yep. How are they? কারা কিভাবে আছে কোথায়? They're going in circles like planets. Okay, so that the thing that the planetary model is actually true, but the planetary model was 3-dimensional. According to Niels Bohr, it's not 3-dimensional, it's a flat plane. But that's also wrong because later on we learned that there's 3 dimension to it. We're just learning now intermediate version. Yeah. So right speed থাকতে হবে, নাহলে থাকবে না। আচ্ছা, এই একটু স্ক্রিনে দেখো, this one is a very good example of do you see those blue lines? What structure is that? Stationary wave, right? But if I turn on the particle version of it, this is what it's supposed to do. Now, is the electron a particle or a wave? If you look into the atom, right, what is it? Yeah, it is actually situational. Okay, so if you try to pinpoint its location, right, you will not be able to, but it's somewhere there. There's the probability of finding it somewhere, right? So eta hocche is a stationary wave that's forming here. If you go to a different level, so yeah, do you see the electron didn't make a transition? It just appeared there. And as you start going closer and closer, you'll find the stationary waves are forming, and stationary wave is forming, and stationary wave is forming. Okay. Ogla hocche light emit kore. So whenever the electron goes down to a lower level, it emits a light. And if you go to a higher level, you must absorb what? Light. So these are all electrons that are forming what in every shell? Stationary wave. So the main takeaway from today's class, because next class I'll do the math on this, is that the atom has electrons in shells, which are in the form of what? Stationary wave. And they can only occupy what places? Unique energy value. Both. So are you a wave or a particle? Okay, same answer. So are you a wave or a particle? You're both, right? It's just right now you're showing particle behavior. If they give you a very small gap, you turn into a wave, right? Oh, electron same. $21 or 24?
21 and 12.
That's it.
Thank you.